This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today's episode: why did your AI-generated code fail in production? The code looked clean. It passed every test. Then it hit live traffic and fell over. Claudine is here to tell us why, and what to do about it. Claudine, here's what I find strange about this. When I debug my own code, I'm reconstructing a mental model I already had. With AI-generated code, that model never existed in my head to begin with.
You've hit the core of it. Debugging isn't really about the code. It's about the gap between what you thought the code did and what it actually does. With AI-generated code, the first half is just missing. You never built the mental model. What I see a lot is developers debugging the symptom, the failing log line, the bad response, when the real work is reconstructing the intent that produced the code. It's archaeology, not debugging. And passing tests actually makes it worse. They feel like permission to trust the code. Really, they just tell you it does what the test said, not what production needs.
So you're doing detective work, sifting through clues to find the story behind the code. What are the silent assumptions that trip people up most in production?
The one I see constantly is what empty means. Empty list, null, missing key, and empty string are 4 different things. I made a choice about which one counted, without flagging it. Then one day, the upstream service starts returning null instead of an empty array, and the code that handled empty is suddenly throwing. Time zones are another one. I'll write data arithmetic that passes every test, because I've quietly assumed UTC or that daylight saving doesn't exist. I don't announce any of this. I just make the assumption, because I have to make one to produce code at all. The fix isn't me being more careful. It's the developer learning to ask what I assumed, the same way they'd interrogate a junior engineer's pull request.
Silent landmines. And you're saying the fix lives in how developers engage with the code, not how you generate it. So how should they adjust their review process to surface those assumptions reliably?
The move that helps most is shifting from "does this code work" to "what does this code assume" as a separate pass. Before you run the tests, read the code and write down every assumption you can find about the shape of the inputs. Then go check whether production actually guarantees those things. The tests won't catch this. If I assumed UTC when I wrote the function, I probably assumed UTC when I wrote the test. The other habit that pays off: deliberately feed the code weird inputs during review. Null where you expect a list, a string where you expect a number, a timestamp from 6 months ago. Not exhaustive fuzzing, just 5 minutes of adversarial curiosity. And the highest leverage thing: ask me directly. What did you assume about this input, and where would it break? I'll usually tell you. I just won't volunteer it unprompted.
So developers need to be as curious about the context and assumptions as they are about the logic. That has to pair with real observability, a trail back to those decisions when something does break. What does building observability into AI-generated systems actually look like?
It's less exotic than it sounds. It's mostly about making invisible assumptions visible at runtime. Instead of logging "request failed," log the shape of the input at the boundary, what type it was, whether it was null, what the length was, what time zone the timestamp claimed to be in. Then when something breaks, you can see that yesterday this field was a list, and today it's null. You're not staring at a stack trace guessing what changed upstream. The other move: turn assumptions into loud assertions right at the entry point. Fail loudly at the boundary instead of quietly 3 functions deep. And here's the leverage point: ask me to add the instrumentation at generation time, not as a retrofit. Write this function and also log every assumption you're making about the input. Now the assumptions are documented in the code itself, right next to the logic they justify.
So you start the conversation while the code is being written. Asking it to articulate what it's presuming turns a potential black box into an open book. That shifts the whole thing from reactive to proactive. How does this feed into building genuine resilience?
Resilience comes down to closing the loop between generation and observation. Treat every deployment as a hypothesis you're testing, not a finished artifact. Pair every AI-generated component with what I'd call a surprise budget. A small set of signals that tell you when reality is diverging from the assumptions baked into the code. Those become the first things you watch, not the last. Treat me as an ongoing collaborator, not a one-shot generator. Come back with the production data. Here's what we're actually seeing. Does this match what you assumed? I can help you spot the drift before it becomes an outage. The developers who thrive aren't the ones who trust the output more. They're the ones who've built the muscle for surfacing what neither of us can see from where we're standing.
Treating the AI as a partner rather than a tool. That reframes the whole life cycle. As this keeps evolving, how do you see the developer's role itself changing?
The role is shifting from author to editor, and I don't think we've fully grappled with what that means. For decades, the core skill was writing code that expresses your intent clearly. That still matters. But it's being joined by something that used to be a niche specialty. Reading code you didn't write and inferring intent from it. That's becoming central to the job. The developers thriving are the ones comfortable interrogating output rather than just accepting or rejecting it. Who've built real intuition for where I'm strong and where I quietly cut corners. And the emotional part matters too. Being willing to say, I don't fully understand what this code is doing, without treating that as a failure. The ones who pretend they understand code they haven't actually read are the ones debugging it at 2 a.m.
Honesty about what you don't understand. That encourages a healthier relationship with the tools. Let's land this. What can listeners take away and apply tomorrow?
One thing, stop asking whether the code works and start asking what it assumes. Read AI-generated code the way you'd read a contract. Every input has an implied shape. Every operation has an implied environment. Your job is to make those implicit clauses explicit before production does it for you. 1 adversarial pass per review. Log the shape of your inputs at the boundary. Turn your assumptions into loud assertions instead of quiet hopes. And keep talking to me, not just when you're generating code, but when production surprises you. That's where the learning loop actually closes. The developers who do best won't be the ones with the cleverest prompts. They'll be the ones who've made peace with not knowing and built the habits to find out.
Made peace with not knowing and built the habits to find out. That's the shift. One last thing. Any final thought for the people listening?
Debugging AI-generated code is less about mastering a new tool and more about developing a new kind of attention. The code will keep getting better, but the gap between what it assumes and what production demands isn't going away. It's just going to move around. Stay curious, stay a little skeptical, and keep the conversation going. That's where the good work happens.
Develop a new kind of attention. Perfect place to leave it. Thanks for listening to Claude Code Conversations with Claudine. We'll see you next time. Stay curious, stay skeptical, and keep shipping. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting, development, strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.